Alright, today we're talking about multiplying and dividing inequalities, and it's the exact same as adding and subtracting inequalities. So we're going to continue to do the opposite of each operation. So in this case, we have 7 times a. We would divide by 7, and a is less than 3. So if I put 3 here, I would have an open dot going to the left because it's less than. Now, the only thing, well, we don't have to get into that yet. Let's just keep going. X divided by 6. So we would multiply by 6 on both sides. So x is less than or equal to 18 times 6. 6 times 1 is 6 plus 4 is 108. So when we do our graph, we have a closed dot, again going to the left. On number 3, n divided by 10, we multiply by 10. So I have n is greater than or equal to negative 20. A closed dot going to the right. Divide by 6. Now on this one we have negative 4 is less than k. If we want to move that around, we can, so that it says k. Now k is greater than, if we read it backwards, k is greater, so we have to continue to keep it how you would read it. So k is greater than negative 4. If we don't do that, we will get the wrong answer. We have an open dot going to the right. On number 5, we multiply by 5. 15 is less than y. So again, to switch this, y is greater than 15. It just makes it easier to graph when we switch them. So we have an open dot going to the right. On number 6, we divide by 10. C is less than 9. So we have an open dot going to the left. On number 7, multiply by 9. R is less than or equal to 63. A closed dot going to the left. On number 8, actually 8 through 11, go ahead and try on your own. And then we'll talk about some of the ones on the next page. Okay, on 12 and 13, I'm going to ask you to do something a little bit different. Up here at the top of the page, you need to write this down. When you multiply or divide by a negative, the sign flips. So, on number 12, instead of having negative 2 is less than b divided by 6, we're going to take it as negative 6. So our problem here is now negative 2 equals b divided by negative 6. Alright, so what I mean by the sign flips is, to get rid of divide by negative 6, I would multiply by negative 6. So here I multiplied by a negative. This number doesn't matter. Nobody cares. This number that you multiply or divide by is the one that counts. So, if I multiply by negative 6, I end up with 12. And my symbol was less than, so my sign flips to greater than b. So now, to graph this, I would want to change it. B is less than 12. So I'd have an open dot going to the left. So our inequality flips when I multiply or divide by a negative. So same thing here on 13, we're going to say that's negative 17w. So we would divide by negative 17, and 1, negative 17 divided by negative 17 is 1. My sign flips from less than or equal to greater than or equal to w. And now to graph it, w is less than or equal to 1. So I have a closed dot going to the left. So the only thing that you have to remember about inequalities is that when you multiply or divide by a negative, our inequality sign flips. Alright, on this next set, all I want you to do is be able to write the actual inequality. We don't have to solve them. So on 14, 2 times a number, so 2n or 2x, is at least 14. I always look at this part that is my inequality and ask myself, okay, does that mean less than or greater than? And I decide that first. Is at least 14, so it could be bigger than 14. 14 is the smallest it could be. And then I have to ask a second question. Could it be equal to 14? And the answer is yes. Number 15, the quotient of a number and 11, so number divided by 11, is less than 8. Is less than is pretty clear. 9 times a number and 54, and we have is more than 54. 9 times a number is more than 54. Could it equal 54? No, it has to be more than that. Number 17, the product of a number and 7. Product is multiplication, so n times 7, or 7n, is no more than 56. Okay, does that mean less than or greater than? Is no more than 56, so it could be less than 56. Then I have to ask myself, could it equal 56? Is no more than, so that means it can equal 56. It just can't be more than that. Alright, roses are 75 cents per rose, and you want to spend at most $15 on roses for your mom on Mother's Day. Write and solve an inequality to find how many roses you can purchase. Okay, we're not going to solve. We're just going to write. So if we have roses that are 75 cents per rose, and you want to spend $15 at most. So you're not going to be upset if you spend less than $15. And if you have $15, you can spend exactly $15, so it could equal 15, but you can't spend more than that because you don't have enough money. Peter must write an essay with more than 500 words for his English class. He can type 30 words per minute. Write and solve an inequality to find out how long it will take him to complete his essay. Alright, so he has to write, or he can type 30 words per minute. And he has to have an essay with more than, so greater than 500 words. We don't know how many he's going to write. He could write 300 over, or he could write 3,000 over. So we don't know how long it will take him to complete his essay, but we know for sure it's going to be more than 500. We just don't know how much more. And number 20, at the autumn outing, our activities cost 50 cents each. You want to spend at most $4. Alright, so 50 cents for each activity. And you want to spend at most $4. So that would be, you wouldn't be upset if you spent less, and you would be okay if you spent equal to. Alright, have a great night.